Okay, so this was our assignment from yesterday, this Brain Pop Skate Park. So I wanted you to have this and play it yesterday so that you could see the differences in the potential and kinetic energy. So let's kind of check it out. So we can grab our guy and we can put him up here, and I want to show the pie chart. So I want you to see where the potential energy is and where the kinetic energy is. So if you look right here, kinetic energy is green. The potential energy is blue. So let's see if I can stop him. Where's my pause button at? Hang on, let me figure him out. Come over here, you little stinker. How do I pause? Wait. So we'll just look while he's moving. So if you look when he's at the top of the hill, that pie is completely blue. So that is all potential energy when he's way up here, right? But when he gets down here in the bottom, see how it's all green? There he is again, it's green. And it changes back and forth depending on where he is on his hill. The potential's at the top and it's kinetic at the bottom because he's moving as fast as he can. Kind of neat, right? So we're going to use a pie chart like that to describe potential and kinetic energy. Okay, so let's look at this roller coaster because this has a really big pie chart on it, and I think I can push pause on this. So let's play and look right here. So you see how the potential energy is getting higher the higher they go? Woo, and it turns into kinetic, back to potential, and there we go. Kind of cool, right? Okay, let's play. Oh, the potential. Woo. The faster they go, it turns into kinetic energy, right? So at step 1, it's all potential energy. See how we're at the top of the hill? We got all potential energy. They're hardly moving at all, or they're moving super duper slow. So up here at the top, we're all red because it's all potential energy, okay? So let's go down to step 2. This is the part of the hill where they're moving the fastest, and this is almost all kinetic energy, right? It's kind of cool. So let's go to 3. That kinetic energy, we're going back up a hill again, so it's starting to slow down just a little bit, so the potential's building. Up here at 4, we're upside down, which is kind of crazy, but that's back up at the top of a hill, so the potential energy is huge right there too. It's not all potential because they're still moving a pretty good clip, but there's a lot of potential energy right there. And then let's go back to 5. So we've come back down this hill, we're moving pretty fast again, and we're all kinetic energy again. And then here we're going back up a hill, so let's look at 6. When we get back up the hill, you see how the potential energy is building again. It's kind of cool, right? Y'all want to see it in motion again? There's play, and we'll watch him go through it again. Oh, that's pretty cool. I love it. Okay, so I gave you the link to this roller coaster too, so that you could play with it and kind of pause it and do the steps yourself. And maybe that would help you kind of figure out where the different pieces and parts of potential and kinetic energy are as far as a roller coaster goes. So next, we're going to talk about roller coasters. So here we have this paper right here. Okay, so this is my potential and kinetic energy notes. Okay, so you don't have these obviously because you're sitting at home, but if you wanted on a piece of notebook paper to draw a roller coaster that looks just like this one here, put your little car on there in the same places as I've got on here, and then label them A, B, C, and D. That'd be super cool. And then you could take notes with me. And again, you're going to get an extra credit point for our graphic organizer. And you're going to get another extra credit point for doing this and sending me a picture of it. Okay, so there's 2 possible chances for extra credit points right here today. Okay, so the first thing we're going to do, we're going to describe the energy at point A. So let's look on this side right here. Point A is way up at the top of the roller coaster. And remember, at the top of the hill, we've got the max potential energy. So we're going to flip this over again, and we're going to say max potential energy, because that's the point, the highest potential energy on the roller coaster is going to be right up there at the top. Okay, so that pie chart that we've been looking at, we're going to make a pie chart right here, and we need to figure out what kind of energy to put in there. So if it's max potential energy, that pie is going to be all PE, right? So I'll put all potential energy. Okay, so let's look at point B. We need to describe the energy at point B. So right here at point B, our car is about halfway down the hill. So I think that energy is going to be moving from potential into kinetic energy. So the energy is transferring from potential, so I'm going to put PE, to KE, from potential energy to kinetic energy. Okay, so if we were to look at a pie chart at that section on a roller coaster, let's go ahead and draw it. We would probably have, oh, I don't know, there's some middle of it. We probably have, I'd say about this much or so potential energy left. And then this over here, because it's moving pretty fast, would be the kinetic energy. So it's transferring from potential into kinetic. Okay, so let's look at point C on our roller coaster. Point C is all the way down here at the bottom of that first big hill. So that roller coaster is going to be going as fast as it's going to be going on this roller coaster right there. So that is maximum kinetic energy. So I'm going to put max kinetic energy. Okay, so we'll draw us a circle. And what should we put in that circle for max kinetic energy? That's right, all KE. All KE for kinetic energy. Okay, so next we're going to look at point D on our roller coaster. Right here on D, our car has moved from the max kinetic energy, and it's going back up a hill. So our energy is going to be moving from kinetic into potential. Okay, so we're going to say energy transferring from kinetic to potential. So energy is transferring from kinetic to potential. So if we drew our circle, our pie chart, it might look about the same as that one there, but we'd be changing them around a little bit because we'd have a little bit more kinetic energy, I'm sorry, a little bit more potential energy than the kinetic. Okay, so remember, you take these notes just like this, draw me a roller coaster, something along these lines, take a picture and send it to me. You've got a whole nother extra credit point. Y'all are amazing.